We're going to do some examples of the cross product, or computing the cross product. We have two examples here. For each of these vector pairs, we want to find u cross v, v cross u, and v cross v. Let's take a look at the first one. So let's go ahead and construct our diagram. I, j, k, I, j. So we have negative 2i plus 4j. Now we don't have a k, so we write in a 0 for the k value. And then negative 2 and 4. And then we have 3, 2, 5, 3, 2. So then we're going to go down the line here. So that's 20i plus 0j minus 4k. And then we're going to go the other way. Minus 12k. Recall, if we go right to left, we subtract it. Minus 0i. So this is negative 10, but we're subtracting, so we add 10. So u cross v then is 20i plus 10j minus 16k. And that's u cross v. Now, to get v cross u, we're going to do the same thing. And we're gonna construct that. So we're just gonna flip those two, right? We're gonna say 3, 2, 5, 3, 2, negative 2, 4, 0, negative 2, 4. So we just repeat the same process. So we go through, we get 0i minus 10j plus 12k. Again, we're subtracting negative 4, so it's positive 4k. Negative 20i. And then 0j. So v cross u is going to be negative 20i minus 10j plus 16k. So I want you to notice something. U cross v and v cross u are parallel vectors, but they're in the opposite direction. So, and they have the same magnitude, right? They have the same absolute value for each term, 20, but this one's negative and that one's positive. This one's negative and that one's positive. This one's negative and that one's positive. So it's the same magnitude. It's a parallel vector basically, but it's in the opposite direction. So u cross v is always equal to negative v cross u. That's one of the basic properties of cross products. Now to compute v cross v, I'm going to go ahead and let you know that v cross v, if you recall from the previous section, v cross v is always the 0 vector. So I'm not going to write that here, but if you'd like to compute that, fill that diagram out, do v cross v, and prove to yourself that that's equal to 0. So let's do number 2. So we have 3i plus 5k, so that's 3. There's no j term, so it's a 0. 5, 3, 0. And this one we have 2, 3, negative 2, 2, 3. So if we come down, we have 0i plus 10j plus 9k. Well, that's another 0k minus 15I minus negative 6, so plus 6, so we have negative 15I plus 16j plus 9k. So let's see. All right. Now recall that V cross U then would simply be 15I minus 16j minus 9k, because it's just the negative of U cross V. Now I guess since we have space, let's go ahead and do V cross V. 2, 3, negative 2, 2, 3, 2, 3, negative 2, 2, 3. So coming down, we have negative 6I, negative 4j, plus 6k, minus 6k, minus a negative 6, so positive 6I, minus a negative 4, so positive 4j. So for those of you who are familiar with linear algebra, what you'll notice is that if you look at how to do this with determinants, you will end up with two rows that are exactly the same. And if you remember from linear algebra, if you have a matrix and any two rows or any two columns are identical, the determinant will always be 0. And those are examples of using the cross product or computing the cross product.